Thank you, Ola, for accepting our invitation to present today. We'll have another session on the AI, this time on how students can act as teacher in the challenge with teacher AI. Thank you for coming and enjoy the session.
Thank you very much. It's a pleasure to be here. I look forward to hearing feedback and comments. So I think I'll talk about one application we used in a big course that I think is a little bit fun or a little bit different from other applications prior to teaching. Then I will discuss like two kind of obvious applications of AI to teaching, and like I think they're worth of discussing. Okay, so let me start. There are like, it's not that LLMs are like always brilliant, right? So here's an example. It's not from today's, maybe they've updated, but it's 6 months ago. Already newest models is quite fun. So solve a riddle for me. Then sure, I'd happy to help me. So what's the riddle? So a man and a woman are standing at the river. The man has a boat. How can both be brought to the other side? So it's a very simple riddle, like, they can just take the boat and go to the other side. But because you have kind of pre-prompted this, that it should be a riddle, it completely overthinks, right? So the man rows the woman across the river to the other side. The man rows back, and then he rows himself around. Okay. And so on. Okay, so actually my initial experience also was very bad. So I wanted to generate exercise. My daughter was, I guess, 6 at the time, so I wanted to generate exercise for her to learn to read. So I was not very impressed. But then what happened was that I realized if I just use, like, I program in Python. Actually, I'm not doing my program, but I use the language model to generate Python code to apply then to the LLM. Then I actually could, like, in half an hour, generate exercise to my daughter. Like, these matching games and whatnot, so I can generate tons of exercise for my daughter. And this was actually, I also brought it to her class, so they liked it. So then I realized, okay, so I'm also a teacher. And what I'm teaching, the background here is that I'm teaching, the biggest course I teach is the second year bachelor course in algorithms. It's like a first algorithms course. It's basically the same across most universities. And what has happened is, at least when I joined, like in 10, 15 years, we have gone from 230 to, last year it was 540 students, maybe this year it's 510 students. So it has been quite a lot of increase. So the question was like, okay, so there's things that are negative here is that there's less interactions, and something I really don't like is multiple choice question in exam. I didn't like it as a student, but now I do it as a teacher. Okay. So then that was the first idea. So flipping the classroom. Actually, what we did is to flip the roles. So instead of me explaining to the students get to explain. So this is known that this is good. Like I saw a talk by Pierre Dillenburg when I started. It's good. Like if someone explains, it's the person that explains that learns the most. The challenge is like, how do you make 500 students do that? Well, here is, so that's one my English is to listen. So here what we can do is we will see how we have done this. So we have instructed like a large language model to behave as a student. So the students have to act as a professors teaching the most important concept of the course every week. And then I felt like maybe we can help in grading. And we'll see how to do that. That's not ready to be. So I think what is ready to be used, and I saw that they use it also at ETH. There's a professor at ETH that does this. This is to check consistency and to check for bad grading. So like the way I could use it so far was to see that if there was a TA who graded that was completely disagreeing with the LLM, even though the LLM follows that student's grading criteria, I could look into the grading. It turns out that TA did a very bad job. And you could also imagine that you can look at exams that have similar solutions, but you can detect that they got very different gradings. So this is not ready. So what is ready is we'll see later. So I think these two are obvious applications. We will see many people, but that's also we will have now that they can watch our lectures and then ask context-dependent questions. We will discuss this later. Okay, but what we really have used is flipping the roles. So basically, as I said, every week the students will like explain the most important algorithms in our case of the week. And then once they have finished the explanation, they will go to a multiple choice quiz. Okay, so maybe I can illustrate this like as a demo. Let's say we have a lecture on popular initiatives. There's a lot of steps. You know, you want to draft the initiative first. You have to write some specific thing that you want to accomplish. Then you need to collect 100,000 signatures in 18 months. Then the Federal Assembly has to recommend acceptance, recommend rejection, propose a counter-proposal. There's a debate, campaigning. There's a vote. Importantly, it's like double majority to pass a popular initiative. This means, you know, 50% of the population and a majority of the cantons. And then you have to implement it and so on. So then usually people are tired, right? They don't like to listen to this. So then what we can do, what we are asking the students to do, is like I show you, is that they will then, let me see if I can find it. Right. You can also go here to this course. Okay. So then what the students will see right in our course is maybe the algorithms, but here we just did as an example popular initiative. I already did this, but we can try to do it again. Okay, so I'm here to explain. Could you start by explaining how the process initiated? Okay, you have a graph proposal. And then like you saw, okay, that's good to start, but the graph is need. What's need to be in after? Okay, we have to collect. Okay, let's say we say something wrong. Have to collect 100,000 signatures within 12 months. Then okay, this one all gave away the answer. Not good. Okay, how can it? Yeah.
Previously, you also brought up signatures, and there was no mention of signatures, right?
Yes, because we will see how I instructed. I instructed this very kindly. Okay, now what can I say? They can recommend acceptance, rejection, and what is a counter proposal. Okay, you can also write in okay, double majority. Let's say if it a majority of women, let's say, and a majority of men. Yeah. Yes. Okay. Yes. Okay. So you need to have a majority of the cantons and of the people. So then what happens is, now it was not well calibrated, so it gave up, but what we do, sometimes it's not perfect, right? So it will accept the explanation of the wrong algorithm in our case, but then we send the whole conversation for a second feedback, and then they will do the quiz, right?
Just ask a question, Ola.
Yes, of course.
In the beginning, you said you wanted to invert the roles in the sense that the student explains to an AI agent. The demonstration you had, how it felt like the AI was rather tutoring and bringing up your issue. So did you evolve in what role you wanted to give the agent?
No, I will explain. This is just because this is bad. This yeah, I agree. No, that was wrong. Sorry, I just have to finish this. So now yes, I agree with you. This was not a great demo. And like the reason why it's not so great is that so here kind of to make this work out without me getting stuck, basically I had instructed the student, I'd say, to explicitly ask for these stuff. Okay, so it followed really these steps. That's just for me to not get stuck in this demo. If we look at how we have instructed him in the course, it's much weaker in the sense that here we have really tried to say, like, you only should understand Dijkstra's algorithm. And if you try it on these, now I don't know how expert, but then it will not. We have like kind of tried to find a middle ground where it's not like asking about all the details, but also not giving away. So here it was bad instruction for my part.
So when I did the Dijkstra,
yeah,
and it was at some point getting me to talk about the data structure, priority queue.
Yeah.
I mean, this is not mentioned here, is it?
Yes.
Yes,
It's not
it's not mentioned,
yes.
right? But a student wouldn't necessarily think about priority queue if I was explaining to them. They would just say it's okay, right? And assume some sorted list or something. So in some sense, model is a bit too advanced.
So when we teach Dijkstra, we teach it with I think most people would teach it with a priority queue to get the right running time.
Yes, yes. But I'm just wondering whether you're assuming that LLM is a good model of a colleague, let's say a colleague from UNILD, whom we are supposed to explain Dijkstra.
No. This is good for our undergrad students.
Okay.
Like for example, now if we go into the details, if you want to explain Strassen, there we had big problems. Strassen is like a matrix multiplication algorithm that's a little bit complicated. Then it required the students to remember all the formulas, which is not so important. So there we had to like really fine tune the prompt so that it would not go down to those details. But for Dijkstra, I think it's reasonable to go to private.
No, but that's not my. I'm not saying this should work for the students. I'm just saying, what do you mean by apprentice, right? What is the level of apprentice? An apprentice that says, oh, but what about priority queue is a somewhat advanced apprentice.
Oh.
See what I mean?
So, okay, my goal is for them to understand the algorithm completely, not to explain to a student that is happy to just not understand the algorithm. Okay, so what we actually did was then, right, we had 500 students, so what we could do is, to do a little bit of a A/B test. So half the students got to explain and half got to read. And then, of course, you can measure the differences. So it's actually a big data set. It's like 200 students in each category. So yeah, so each exercise, 200 students got to explain, 200 students got to read, and then they got to do the same quiz. So first of all, the students loved it, and they also like it this year. So I got like students contacted me, we'll see help me develop it. And like very preliminary stats is that, not surprisingly, the students that do the explaining are faster in completing the quiz than the people that read. My answer to, like, if you, like, it's not surprising because the people that read, they don't read at all. So they just click past read and then they see the quiz and then they will look for the information they need to solve the quiz. Okay. But they cannot do that if they explain. Yeah, so it's the correctness, what not actually surprising to me, not such a huge difference. And yeah, you can use this. So they actually use it also at Stanford for teaching algorithms in one course, the same system. And you can try it out. That's one thing we did. This, I think, is actually.
Can I ask you something?
Yes, of course.
How do you test it? How do you test whether your apprentice, your bot apprentice, is not leading them the wrong way? Because there's a lot of feedback that they get from your bot apprentice during giving of explanations. And, even if we ask a bot a very simple question, it can sometimes give us a wrong answer. So I'm trying to
so there was two ways. There is they can flag conversations. They can report conversations if they detect themselves that the bot is behaving in a bad way.
Mm-hmm.
And then there is the A/B test, right? Where we go onto a quiz and we can see how many errors do the people that explain this do compared to the people that didn't explain, that read. So if it would be highly misleading, you would expect the people that explain to do more errors on the multiple choice where there is like no ambiguities.
Okay.
Of course, the fine tuning we did by trying it ourselves, but there was not, I should also say that the comparison between the explaining and the reading was the immediate quiz, not the final. You could imagine, that there are longer consequences of this.
Mm-hmm.
But that would be extremely hard to measure because one group, because ethical concerns, we cannot split the class. So every week, one of the groups explain one of the algorithms and the other group explain the other. So the impact on the final exam, I guess, would be 0.
Mm-hmm.
Well, you could measure per individual questions also.
That's what we did, on the multiple choice. But if you had the final questions, It is not I have exact this. Yes.
With correlative questions are topic-wise and your quiz.
Oh, I see. Yes, but here, for example, they explain 2 algorithms for finding the shortest path 1 week. So do one, and then the other one explains 2 different times for dynamic problems. It's not like they do different algorithmic techniques. But I don't know a good way of doing that. Okay, so for grading, what we did was, basically the problem is that current system optimized multiple choice questions. And I noticed that these models are actually very good, surprisingly good to understand handwritten text with handwritten graphs. That was pretty amazing. And then like ANDs, we have to use ANDs, right? Because of data privacy. So then the idea was, okay, so if I have, this is basically, if I have to grade 10 exams, this is obvious to everyone that does grading, I guess. If I grade 10 exams, basically I have to do 10 jobs. Like they're scattered around, there are different solutions to students and so on. If I have to grade 500 exams, there are still 10 kind of solutions. They don't grow with the number of students. There's like typical errors people do or typical correct solutions. So I think the idea here is, what if either I or the TAs grade a couple of exams in each of these typical solutions? Then I could hope that LLM generalizes. I don't just go wild on LLM to grade. I take some example gradings and then I hope that it can generalize. That's what we did. I did a Chrome plugin. So basically, this is what the TA did, and then this is what the Chrome plugin predicts the grading to be. As I said, this of course is happy pitch distance if it would work, and it would lead also. What nice is that now we get tons of questions about previous exams. I didn't solve it exactly as the TA solved it. Would I still get points in the exam and so on? So it's unlikely if you have 500 students, I think, that someone after 5 years comes up with a new solution. So anything that would come here would be close to something most likely that we have already seen. But this is difficult. So this performance is not so, it's not good enough to do grading at the moment. I spent a lot of time fine-tuning based on a specific problem. The TAs do not do that. But what it was good enough at was to detect really bad grading or consistency. So I think that is something, actually, I think they use at ETH. And this is kind of an obvious thing that comes if you just look, everybody does this. So I think there's ethical things and concerns and so on to be discussed here. Okay, then what we have done now, I think is very interesting, very impressive. So this latest model, so what we do is to take the lectures from the course and then we pre-process them. So actually, what you have done is to pre-process the speech, but also pre-process all the visual content down to text. Okay, so we take the whole, like a 1 hour, 50-minute video or something down to text. This allows us to answer queries very fast. And we can see here, it's actually, I would say, I was impressed that it is surprisingly accurate. Let's just see. I think this disappeared. Oh, you have it on your, okay, sorry. So we go here to this, here we have. So now the students don't have this yet, but I tried it with machine learning as well. So this is publicly available videos, right? We have them on Mediaspace. So what we did was to pre-process, this is one lecture of me. So I don't know, we can hear my answers. Okay, you can hear it. Oh, like that is better. Okay, so can you summarize? Summarize video, let's see if it works. Okay, so then it summarizes the videos, and then we can go, for example, this was a pretty difficult operation successor. So there's an easy case, and then there's a hard case. Okay, can you explain the difficult called case 2? Okay, so then it explains this. So, oh boy, can you give an example? So then it actually usually, at least, it takes the example from the slide that I've used. Okay, yes. So here it will then, yes. So here it will then give the example from the tree that I drew in the slides. But you can also ask it, this is the tree, so it gathers that information. It will give the student a step-by-step how the algorithm would run on that example. This is pretty impressive in my opinion. The negatives here is that, well, there are some negatives in my opinion, is that this makes it less attractive to come to my lectures, because now you can sit at home, not only watch the lectures, but you can also get sometimes a better explanation than I did. Another problem is, for instance, this is not very good necessarily for learning, okay? Because one, maybe it's better to have a slightly worse explanation where you actually spend time to understand it than getting it fed to you immediately. So I discussed, actually, it's interesting, one of the students, after I told the students about this, one of the students in my course came up to me and said that they basically use this kind of, he watches the videos at home, but has a ChatGPT next to it. I ask him questions, then it's not connected to the content of video, so you have to pre-prompt it. But he had also noticed that it was not so great for him that it just gave him the answers immediately. So he had so I think that's why I think it would be good. I tell the students that is implemented is that we should have like a Socrates option here. Just as when we explain, we are trying to make it sure that it doesn't give the answers too easily. Here it should kind of guide the students, yes.
Isn't it also that actually if you skip the video, right, and only come back to it when you get a specific question you need to answer,
yes,
then you kind of just only ever query it on the thing that you need to solve, right?
I mean, you cannot do that at exam, but otherwise you could do it, yes. And actually it's interesting, because that's actually I thought was one of the nice use cases of this. Hopefully they come still to my lecture, but if something was unclear, they would kind of just go back to that point of the lecture and ask it. And then when I gave this talk, I gave a version of this time ago, there was like some cost involved, but this is irrelevant now because this year, I ran the same explanation system last year. Now it's 20. I haven't filled account for the whole year, so it's like 20 times cheaper. Last year it costed 1,500 to run this explaining for the 500 students. I don't know, maybe this I've used 50 francs. And this was actually developed by my PhD student Nicola explaining. Then Julie and Julian joined to make some features during the course, and Maxence has made this video watching where we can. So I think what is impressive here is the ability to pre-post the video down to text with keeping the figures and so on, so we can answer questions. And then Tanya and Bob helped with this A/B test and so on. Yes, so that was, I think the discussion was. I think actually I'm pretty excited about this in the sense that I think we will have a pretty big impact on teaching. I don't know if it's good or bad, this LLM, but I'm sure that the students already use it. So I think there's a little bit of a question, what should we teach? Like 1 year ago, the models didn't solve my undergrad algorithms exam. And this year, some of the models solved all the problems in the master course in algorithms, which kind of changes maybe the motivation to teach this. And yeah, this also comes to the last one, how should we assess? Luckily, I have made most of my assessments as final exams, but like the programming course and so on, I think have bigger issues. Okay, that's it.
Thank you.